Okay, so today we are going to be building on Trig, which we've been doing for the last couple days. We're going to just call this Trig Applications. And we are going to be focusing on using angles of elevation and angles of depression. So, if you have the ground and you have some kind of an airplane, okay, and if the pilot is looking, hopefully he's looking straight ahead since he's driving the plane, but if the pilot sees a person down there on the ground, if the pilot of the plane sees the person on the ground, then this is called the angle of depression. Okay, and if the person is looking up to the plane, then this is called the angle of elevation. Now, we make a lot of assumptions, and that is the fact that the ground is completely horizontal and that the plane is flying completely horizontal as well. Okay, so if that is the case, then essentially the ground and the plane's flight pattern, they are going to be parallel lines. So we're looking at this pink line as being the transversal. So what do we know about the angle of depression and the angle of elevation? We know that they are congruent because if lines are parallel, then alternate interior angles are congruent. Okay, so with the relation of trig, we know that we have to somewhere have a right angle, a right triangle. So if we talk about the altitude of the plane, okay, so there with the ground we have created a right triangle. The most common error is that if in the word problem that you are reading, if it gives you the angle of depression, the angle of depression is not in the triangle. The angle of depression is outside the triangle. So you either need to remember that the angle of the depression and angle of elevation are congruent and put it down here, or here's another right angle, so you have to find the complement of that angle. Okay, so let's start with some of the word problems, see how they go. A ship's captain, these are story problems or word problems. A ship's captain sights the top of a 200-foot cliff at a 17-degree angle of elevation. How far is the ship from the base of the cliff? So if you need to pause this to continue writing the problem, please do so. So a ship's captain sights the top of a 200-foot cliff at a 17-degree angle of elevation. How far is the ship from the base of the cliff? Now you know in your diagram you are going to have a right triangle somewhere. But don't start with the right triangle. I need your problem to look like the word problem. So a ship's captain, so a ship, that means we have a boat. Okay, obviously we are going to have some water. And we have a cliff. Sights the top of a 200-foot cliff. Okay, so here's my cliff. And I know it's 200 feet. at a 17-degree angle of elevation. So angle of elevation, I know I'm looking up. So the ship's captain sights the top. So my angle of elevation is going to be right there. There's my right angle, which creates a right triangle. How far is the ship from the base of the cliff? So I need to think. Well, here's the cliff. Here's the base of the cliff. So how far am I looking? Okay, so right there, I just labeled it as X. If it helps you to off to the side, take all the other picture stuff out of it. So there's 200 feet, there's 17, and there's X. What trig function would incorporate all of those three numbers? Hopefully you said tangent. So the tangent of the angle of 17 equals the opposite over the adjacent. Because I have a variable in denominator, I could multiply both sides by X, I could divide both sides by the tangent of 17. I know that in the law of proportions, or a property of proportions, I can just switch that numerator and that denominator, which gives me X equals 200 divided by the tangent of 17. So I'm going to type that in my calculator. Actually, I'll get one of your calculators. This is what you're used to. 200 divided by the tangent of 17. And you get X to be, can't see it, X to be about 654.2 feet. So there's several things that are happening in these problems. One, I have to see this diagram. This tells me you understand where the 200 goes, and it tells me that you understand where the angle of elevation is. It also tells me that you understand to label it accordingly. So we are looking for feet. Okay, do one more of those. Trying to find an angle of depression. Okay, so again we have, I'm not a real big fan of that problem this minute. Okay, so we have from the top of a lighthouse, from the top of the lighthouse, 210 feet high. The angle of depression of a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse. The lighthouse was built at sea level. Okay, if you need to pause it, go ahead and do that. Okay, so from the top of the lighthouse, so we have a lighthouse, we know we're going to have water. Okay, so we have water again. And we know we're going to have a lighthouse. Again, I'm not a Picasso or anything, just make it look like something. And usually has a little light out here and some light. Okay, whatever. Top of the lighthouse, 210 feet high. Okay, and it says the angle of depression, I think this should say to a boat. So if you had someone in the lighthouse looking at a boat, then the angle of depression would be from top of the lighthouse to the boat. So the angle of depression is 27 degrees. Find the distance from the boat to the foot of the lighthouse. So we are looking for, again, that measurement. So if we look at the information that we have, kind of pull all the information out, we have the 210, we have the X, and we have 27 out there, that degree. So that means that we either need to put the 27 in here, or we need to figure out what would make this another right angle, which would be 63 degrees. I'm going to stick with the 27 because I know that the angle of elevation and the angle of depression are congruent. So I'm going to put my 27 degrees there. This one happens to also be another tangent. So the tangent of 27 equals 210 over x. Same thing I did last time is I am going to switch places with those because it is a property of proportions. So I have x equals 210 over the tangent of 27. Just know that not all of these problems are going to be tangent. It just happens to be that the ones that I chose tonight are. It's 210 divided by the tangent of 27, and you get 412.1. And that would be feet. So the distance from the boat to the base of the lighthouse would be 412.1 feet. Again, it just happens that these are both tangent. That is not always the case. I just wanted to make sure that you have examples of both the angle of depression being outside the triangle, which equals the angle of depression inside the triangle. Oops.